Let's see what we got here.
I don't really know how to explain what I did, but I just looked at the x-axis and just like looked at the numbers and just
Yeah. Yeah, and you flipped it, right? So we know that doing a reflection, you're just moving to the other side of something like a mirror. And so it's exactly one unit away from zero in the original, and it's 1 unit away from zero in the new image as well. The distance is maintained from -6 to -5 as 1 unit, and she also maintained the distance here, and the length, the distance of these 2 points are also the same, and so that's really good. Thank you very much. Number 4. Yeah, to give up on the lines, I did a long time ago.
So, the beginning was 0, -2, so that's where I put the point, and I went up 3 and over 4.
Okay, perfect. And so going up 3 and over 4, you know that because your constant of proportionality right here, this 3 over 4x, we also call this, it starts with an S. What do we call this?
Slope.
Slope. Yep, tells us how far to rise and how far to run. Very good. 5, no one did that, so we're not going to go over it. We'll let people solve it online here as well. Let's look at the one I did. So I have 2 equations, and it asks where they intersect, and intersect means when like 2 things cross over each other or run into each other. So what I did was graph out each of these equations and found that they intersected at the x-axis at 4 and the y-axis at 3. And whoever did number 8.
All right, so I looked at coordinate point C, and then so basically the coordinates is 0, 1, so then 0 is x and 1 is y, and then it says x plus 4 and y minus 2. So I did 0 plus 4 equals 4, and then 1 minus 2 equals -1, so the new coordinates would be 4, -1. Yeah, I'm not sure. I was
Okay. Yeah, that's fine. Like when you explain it, it sounds like really good and really nice. So you're thinking sort of correct. You were right. You know that you have to do something with this rule up here, correct?
Yeah.
So what you have is you have this x plus 4. Well, what is your x value here? Is 0 plus 4, which is, you are correct. That would make that 4. And so that is correct. And let's go ahead and check your math on the other one, right? So we said that our C was 1. Our C is at 1, correct? Or our Y, our letter C and Y. And it wants us to -2. So I'm going to take 1 minus 2, and that equals -1. And so you are correct. It took me a second to find it because you didn't show the work. And then when you were explaining it, it was just, my mind wasn't comprehending. And so I definitely appreciate you giving me the time to go over that and look at that, okay? Do you guys have any questions?
No.
Okay. I had this originally made for you for February. So, but then when we got kind of swung around by everything else, I decided to teach more of the traditional note way that we had been doing. And this would have been more of like self-guided work, which you're ready for now. So we talk about slope, intercept, form, and we know that everything needs to be in y equals mx plus b fashion. Right? And so what this means is that I have a total that is equal to a rate with an unknown plus a fee if I'm doing a word problem. Does anyone else have any way that they could describe this? There's no right or wrong answer. Just what does the M mean? What does the B mean? So you're looking at the equation, and for me, I said that the Y is the total, M is the rate, and I'm actually going to put like rate of change. Times the unknown and the fee if I were doing a word problem. What else can the letter M mean? If we look at this bigger box down below this, what else can the letter M mean? You can type it in the box if you guys don't want to talk. And go back and look at number 1 in the do now as well.
Someone wrote in the chat, it's the slope.
Okay, slope. All right. And then what would the y-intercept be? Oh, I just gave that away. Intercept. What else can it be? B for
Beginning.
Thank you. And so M is, if B is for beginning, what is M for?
What you end with?
What you what? Oh, you said divide with. Okay, I like that. So it's something that you move, right? Or do the inverse property of. To isolate. Okay, I like that. Can you guys see that when I write that like that? Okay, so take a second to go ahead and write out y equals mx plus b on your documents in a way that you guys would understand it. And when you're ready, just kind of give me like a I'm ready in chat or so forth, okay? How do you best understand slope-intercept form? So m is equal to y2 minus y1 divided by x2 minus x sub 1. I'm just kind of sharing my thinking of like how I remember this. Times whatever x is. And that's how I think of it. So when you're ready, just let me know and we'll kind of start dissecting our examples, okay?
We have one person done.
Okay, thank you. Okay, I got another one. Let me see. Okay. I'll give you guys about 1 more minute. Okay. Less than 30 seconds. All right. So let's go ahead and look at our examples. In the first two examples, we're going to be looking at word problems and then pulling out the slope and the y-intercept in order to write an equation. And this was something that a lot of you guys kind of opened but then didn't finish. And I don't know if it was because you were just intimidated by the words or what. So we're going to kind of look at those and see how we can dissect those. So let me get a volunteer to read about Susan. Anyone can unmute themselves.
Susan is planning on saving for a vacation. She currently has $230 saved already and is planning on saving $55 a week. Write an equation to represent the amount Susan has saved as after a certain number of weeks.
Okay, so what variable do I know? Do you guys think that I know? Do I know how much she saved? Do I know how many weeks she has saved? Do I have any information that I could possibly put this equation together? What do I know?
So she started with $230.
Okay, is that going to represent what she has saved or how many weeks?
What she has saved.
Very good. Let S represent the amount saved of $230. Good job. And we have $55 per week. So what variable are we going to use per week? Based on the word problem, what variable are we using for the word week?
W.
Yep, let W represent weeks. And do we know the weeks?
No.
Yep, that's our unknown. $55 is a... What does 55 represent? What kind of keyword? She plans on saving. So I had is planning. So does that mean that she has it or that she would like to save that much each week?
She would like to save that much.
Yeah, so she would like to save that much each week. So she has a rate or an idea of the amount she wants to move. So keywords, movement and rate, the amount she wants to move each week. So the amount she wants to save or move to her savings each week. So just by looking at the word problem and using my vocabulary, I was able to do a couple things. Number one, S represents the amount saved of $230. So this means that she has this. Is this going to be letter M or letter B in our equation? And if you have to, go back up here and look. What are
Letter M?
Okay, so letter M means that we would move this. This would be the rate at which she saves every week. Is she saving $230 each week?
No.
She's doing what with it?
Beginning.
Beginning. Nice. Good job. So $230. So we are going to begin with plus 230. So what is my rate then?
55.
55. And do I know how many weeks?
No.
No. Do I know the total? Do I have like she earned $1,000?
No.
Nope. So I'm simply going to put my equation down here, and it's going to be y equals 55W plus 230. I started with $230. I want to save 55, but I don't know how much I want to save up to or how many weeks I'm going to save. And that's just a simple equation. Now, if I said that you are going to save for 2 weeks, how much money would you have at the end of 2 weeks? Let me get you guys to figure that out and just everybody post their answer somewhere in this area. I'm just curious. If I wanted to save in for 2 weeks, how much money would I have altogether? Yeah. Yep. Very good. And here's why.
155, I guess. I don't know.
Who is that talking? Do you hear that?
Yeah, I don't know who that was, but one person put their answer on the chat.
Yeah.
I don't know who that was. But the person on the chat had said 340.
Yeah, that's what was said as well, I think. But I was just like, why do they sound like a chipmunk?
I don't know.
Okay. All right, guys. So check this out, okay? Say thank you to the people who answered. Can someone identify themselves as the chipmunk? Let's say X is this. And then we have that this is Y, okay? If I'm at 1 week, then I'm just going to take 55 plus 230, which only gives me 255. Or, yes. No, 285. I don't know why I said 255. My brain is skipping my soul here. Okay, so all I did was multiply 55 by 1, where my W is, okay? Now, if I want to say for 2 weeks, I have to take 55 and multiply it by 2, and then add that 230. So my 230, add it to 110, gives me 200, or gives me, 345. Are there any questions about how we would use the equation? Okay, let's look at the next one. Let me get a volunteer to read it. Don't be scared. Let's get someone to read it. I can sing you songs all day. I will be here to sing to you. There we go.
Has already traveled 300 miles of its trip. It will continue traveling 140 miles each day. Write an equation to represent the miles traveled based on the number of days that have passed.
All right, so D is going to represent what, guys?
Number of days.
Nice. Do I know how many days I traveled?
No.
No. This is unknown, okay? So this is going to be my what in the situation. Is this my X or my B or my M?
The X.
Good job. Nice. I like how you thought about that and then responded. Good. It has already traveled 300 miles. So let M represent the number of what?
Miles traveled.
Miles per hour. Nice. And do I have some of that information already?
Yes.
Yep. And that represents my what? My M or my B?
Your M.
Okay. So I like how you're thinking because you're like, the train is traveling, it's moving. Okay. Here's my question. Did I start with 300 miles on my trip, or am I doing 300 miles a week on my trip? Is it that the rate that I'm going each week, or is that what I already have done?
Sorry, that's my sister. Sorry.
Okay.
Oh.
I was like, why are you talking like that to me? Like, I understand that math is gibberish, but seriously. Go ahead.
I forgot what I was gonna say.
I forgot what was happening too. Okay. So 300, does it represent like the rate that you're going, or is that representing the mileage you've already traveled?
The mileage I've already traveled.
Yep. Represents your y-intercept. You've already traveled this. And I'm going to go ahead and box that as well so that we have that. Oh, I have to go to square information. Okay, so then my other question is, what is this 140?
The rate?
The rate. Yep, 140 is the rate at which I travel each day. The rate in what? What is it being measured in?
Miles?
Nice, in miles. Good job. So I'm going to travel so many miles each day. I have a rate that tells me how many miles I travel each day, but I don't know how many days I've traveled. So we said the M was represented by what number? Read your notes over here.
140.
Nice. And that's going to be measured in miles. Oops, I don't know why it jumped to eraser. I'm having technical malfunctions here. Okay, so 140. And what did I start with?
300.
300. And if you already have 300, is that positive or negative?
Positive.
Good job. So y is equal to 140. What's the variable that I'm using that I don't know?
D.
D plus 300. Okay. And it's as simple as that. Okay. Are there any questions so far on isolating and creating equations with these? Okay. I'm going to draw a T-chart over here. And I would like it if you guys would fill in the value or find the total for my X and then what my Y would be. Okay. Oh, yay. Yay. I did it. 90 degrees. Whew, that was hard. So if X is a number, what is its Y? You can pick any number and so forth. So go ahead. Any number for X, and then you find its Y. I hear a couple people working. Thank you to the person who entered 1. Remember, let me put this. This would be the same as saying D. So X is represented by the letter D in this situation, and Y, or what is my total mileage? Thank you. So if it's 0, it's 300. If it's 1, I just simply am going to add that to it. So what's 300 plus 140? It's going to be 440. So let me show you the work here. So if my equation is y equals 140d plus 300, and I say that x is represented by the letter 1 or the number 1, it's going to be y is equal to 140 times the number 1 plus 300. Okay? And then when I take this 140 and I distribute it into the number 1 by multiplication, that's going to become 140. Plus 300, and that's where I got the 440 from. Does that help clarify on how to find the value?
Yeah.
Okay, perfect. Since I have you, can you read about Lenore?
Me?
Mhm.
Oh, okay. Lenore makes a table of this information in a graph where number of minutes is represented by the horizontal axis and total session cost is represented by the vertical axis. Plot the 3 given points on the graph. These 3 points appear to lie on a line. What information
Go ahead.
about the axis plan suggests that the correct model is indeed a linear relationship?
Okay, so we know that it's linear if it makes what type of line?
Constant.
Constant line. Ooh, I love that word. So let me kind of start some notes down here. It's linear. Nice. That's a reference to our last assignment. So we know it's linear if it's constant. What type of line should it be? Should it be curvy, straight, vertical, straight, horizontal, straight? Can it be like wavy, like a sound wave, or like ocean waves? What type of line does it make?
A straight line.
A straight line and stays at the same rate. Okay, so again, the constant of proportionality is mentioned, the way that it looks on the graph, the straight line is mentioned, and how it stays at the rate of change is mentioned, okay? So how do I find the rate of change? Does anyone remember? What do I have to do with this 70 and this 40 here? So I've started you off on the left, and if someone can just finish telling me what I need to do. What's the equation for slope, or the formula for slope? Okay, so what we talk about this as being is the change between a y coordinate pair and the change between an x coordinate pair or an ordered pair. So when you're reading a chart and you're dealing with functions, a lot of times it's really hard to know what is going to be your x and your y values. But I always think about this. You got to find your 0. So in this situation, my 0 would be up here. And everything else is going to be 1, 2, 3, 4, and 5, and 6, and so forth. So we are counting down. So if I look at this 20 and this 0.40, is that closer to my number 0 or further away? Is it closer or further away? So I put the 0 up here in the upper right-hand corner. Is 20 closer or further from it when compared to 30 and 0.70? Which one's closer?
20.
Thank you. So this would be our x1, and this would be our y1. What would then be the 30 and the 70? If you guys had to guess.
The y2 and y1.
Nice. Not the y2 and y1, but the y2 and the...
x2.
Nice. Okay. So here's what I want to kind of like explain to you guys real quick is that I'm going to pause and let you guys get caught up on writing this. And then while you're writing that, I'm going to type a couple more things and then I'll talk about them. Let's do that first. Okay. So you guys get caught up. I don't know how to write this sideways, but I'm going to figure it out. Do you know?
No. Is there a way to turn it?
No.
Oh my gosh.
Man.
Because you can turn the shapes, but I don't know how you turn the text box.
Let's try this. Why? I think I'm going to do it. That's a really big word to write. Dependent. There we go. It's pretty. All right, guys. So again, we're looking at a graph that represents a function, but it also uses the y or the slope-intercept form when using your function to be able to find out what the equation is. And so the first thing that we have to do when we're working with functions is figure out what are we putting in and what are we getting out. So what do we put into the equation? What do we get out of the equation? And I'm going to type that down here. What do we put into the equation? What do we get out? And what comes out? Another way to look at that is by simply saying what is independent, what is dependent. So what is changing the equation that will affect the result? So if you look here, the only thing changing is 10, 20, 30, 40, 50, 60. The number of minutes is what is changing. But if I do the math up here, I'm going to get 0.30 for each of these. So what can I suspect at 10 minutes will be my constant of proportionality? And I'll show, let's let you guys do the math on your y2 minus y1 to see if I'm correct. I could be wrong. So double check real quick. And you can type up here anywhere you want on this document to do the math.
Someone put 0.10.
Ooh. Okay, so 0.10. So that would be points. We've done something wrong there, huh? So using my slope formula here, thank you to the person that did that. Let's make sure we go over this then. Using my formula, it says my y2 minus my y1. So my y2 is 0.70 minus 0.40. That's because y is represented by what I get out of the equation. So if I put in 20, I'm going to get out this amount right here in dollars. If I put in 30 minutes, I'm going to get 70 cents in dollars. I have to divide whatever I find the difference to be by 30 minus 20. That's going to give me a decimal of 0.3 divided by 10. If you guys can figure that out for me, that would be great. Or can I leave it like this? I can leave it like that. Okay. And the reason I can leave it like that is because this is still y on top. So go back to your constant of proportionality. Y over x. Okay. My y is going to be what value? What value do I have for my y? .70 minus 0.4 is going to be 30 cents. So if I want to finish filling in this chart, and you look right here, if I take 30 cents off of this, this is going to be 10 cents. Oh, that's what somebody was saying. I get it. Okay. If I start at 0 and I take away 30 cents from here, I'm going to owe money. What do I get?
Yes, a cup, Mom.
Okay, hold on real quick, baby. If you guys can go ahead and fill in the chart, that would be very helpful. Yes, we need
Yes. How is the white her computer?
her computer. No scooters in the house. So my rate of change is going to increase or decrease by 30 cents each time. What do I have here? If it increases by 30, increases by 30. Here, if it decreases by 30, what do I have? And you can use a calculator. You have Desmos, so 0.10 minus 0.30. Does anybody know? Thank you to whoever put the 1.30 for adding 30 cents. If I can get someone to add 30 more cents to that at 60 minutes to find out what the cost would be. And if I can get someone to subtract 30 minutes, excellent. Good job. What about here? Good job. Excellent. So does this change as we are going down from 0? Is it getting to be 30 cents? Is it consistent?
It's consistent.
Yes, it's consistent. And so when we look at this graph right here at 10 minutes, we have 50 cents. At 20 minutes, we have 0.3. Oh yeah, here it is. Sorry, that's 40. This is 70, and this is $1. That's what that is. Sorry, I was looking at it. I don't have my glasses on. So 0.40 to $1. So we should expect our line to be what type of shape? If this is consistent and constant, what type of line should we have? Look at your vocab down at the bottom.
A straight line.
A straight line. Well done. So if it's proportional, we draw the line through 0, 0. Make sure you write that down. If it is proportional, we draw a line through 0, 0. And this line is actually straight, but I can't draw a straight line even with a straight line. Sorry. It's the way it is. That's my life, the story of my life. So the line actually would have gone through this little broken space as well. Okay. Are there any questions, guys, on this particular portion? Okay. So when you go back and watch it, it will probably make a little more sense. Let's talk about it real quick, though. When the number of minutes increases by 10, so if I go from 10 to 20 minutes and 20 to 30 minutes, how much was the charge increased? So let's look here, up here, of trying to figure out what is the function telling me to do. In this situation, it was telling you to find the rate or the cost in dollars. So when you went from 20 to 30 minutes or from 10 to 20 minutes, what was your rate? What was the amount? Who knows? Oh, whoa. Yep, 30 cents. So 0.30. Oh, whoa. I'm trying. These numbers are getting better for me, though. This is 0.30. Okay. Let's look. And let's go down to our next question. So the charge increases by 30 cents with each change. So when we say, well, we have to talk about the math, we have to be able to compare the rate to the outcome. So the rate, when the rate in minutes changes, or the number or the rate and cost changes by 0.30. Why did I change put time in minutes here and make sure why did I make sure that I put rate with my constant? Why do you think I did that? Right here, I made sure that rate was with my constant. What did we say that a rate must always be if it's linear?
Constant.
Constant, which makes it what type of line?
Straight.
Straight, and makes it proportional. So I want to make sure that I have the word rate with my slope. So always remember that, and that's pretty much what that question was asking there. Another way that to say this would be the usage charge per 10 minutes of use. Use that information to determine that the increase in cost based on only 1 minute of additional uses. In other words, find the usage charge per minute. So this changes things a little bit. I know what the use is per 10 minutes, correct? So let's look at this. For every 10 minutes of time used, I am charged 30 cents. How can I figure out what I would be charged for 1 minute? What type of equation can I set up? And this is kind of pulling back into a little bit of those 7th grade soft skills. Kind of draw it out here a little bit. You may or may not know it, but that's okay.
A linear equation?
Yeah, it is linear. Very good. Nice. How many of you guys remember those ratios?
Oh yeah, I remember that.
Yep. So 0.3 is going to represent an amount out of how much? I don't know why I put that twice. What does it want me to find?
The usage charge per minute?
So what can I do? It wants me to find minutes or the charge per minute, right? So at the very end, I'm going to have charge per minute. So I know that I can set up a proportional relationship to find charge per minute. I can take 0.30. Oops, sorry. And do I know the overall cost at this point? Yes or no? No, you don't know how much you're going to be charged in that situation. So you have 0.30 over X. You don't know the total charge, but you do know that you are charged for 30 cents for every 10 minutes. Or actually, we could have done it this way. Every 10 minutes is equal to how much per every 1 minute. What can I do when I have this type of linear relationship?
Cross multiply.
Yeah, can you guys go ahead and do that with your calculators and find out what X is equal to for me? What do we get?
Three?
Yep, 3 cents a day. Or 3 cents a minute. And I went ahead and put that like this to represent, like if I had 103, you would know that that was 3 cents. Sometimes a lot of kids get the 0.30 and the 0.03 confused. But if I have 0.3, it's in the 10th place, and this is in the 100th place, which means that that would be 3 cents, okay? And so that was easy to find by setting up a proportional relationship. And we can do that because we know that we found our constant of proportionality. We know that our constant of proportionality was 3/10. That's that y over x. And so then we know that it is 30 cents per however much we're looking for. And we knew that 10 minutes and minutes would go in the same box. Now, I wanted you to create a graph for a hypothetical cost if we had 0 minutes of use. So if we didn't use any minutes, and I'm not going to do the graph right now, but I want to go back up here. If we didn't use any of our minutes on our phone bill or what we're being charged for, would we pay money or receive money? Would we pay money or receive money?
Receive?
Receive. Nice. We would make 20 cents for every 10 minutes we did not use. And to me, that sounds like a really good phone plan. I would never call anybody. Like, I'm not calling you. I'm not calling you or you or you. All right. So what we did here is pretty much for this portion and this portion with these notes is what you will do down here in your independent practice section. Okay. Go ahead and look through that and let me know if you guys have any questions to get you started. And so forth. Okay.
Okay.
Because those are all the examples that I have. Marsh was like, oh God, no, not another child. She's fine. Nobody's doing anything to her.
Can you hear her screaming?
Yeah, she's cute. My dog hears her and he's like, let me rescue.
So we're basically doing the same thing for the rest
Yeah.
Okay.
Yep, that's it. That's pretty much been the whole premise of all the notes we've done all year. I show you how to do it, and then you do it. It's just a little bit tricky on the computer as usual. But do you guys have any questions? If you do, stay. If you don't, you are free to go. I'm gonna go ahead and stop. Oh my gosh, stop this thing. Hey. All right, guys. If you have questions, stick around. If you don't, you're free to go. Do you have questions? Hi, boy.
What happened?